Hello students, now we learn what is power, energy, power factor. As you people have learned in your 12th standard, in your schooling, P is just product of voltage and current. This formula suits well for DC circuits. In DC circuits, power P is equal to V into I. So there is no problem in understanding this. When it comes to time varying quantity, what is meant by time varying quantity? I have a voltage which I am representing here as a sinusoidal wave. So the magnitude of the voltage at one point is 0, at some other point is 1, and at this point is 2, again 1, and again 0. So the voltage varies with respect to time. So this is called as time varying quantity. So when you want to find power, it is defined as the average over a period of time. I will try to find the average for a period of time t. So when I try to find average for a period of time t, I have both positive value and equal negative value. This is symmetrical sine wave. If it is symmetrical sine wave, I will have equal positive and negative value. So when I try to find the average over a period of time t, it will be equal to 0. So in order to avoid the problem, what we do? We go for RMS value of voltage and current. So when you go for RMS value, root mean square value, already in my previous video I have taught you what is meant by root mean square. When you find the root mean square value, the value of voltage and current are complex, and hence the power is also complex. So the complex power is denoted by S bar, which is equal to V bar. V bar tells you it is a complex voltage, and I bar tells you it is a complex current. And what does this star mean? I star tells you it is the conjugate of I bar. Conjugate of I bar. So now let's see this. V bar. V bar is equal to V angle delta. What is delta? Delta is the phase of this voltage wave. Phase is the angle with which it is inclined. Okay. And when it comes to the current, I is equal to I angle gamma. Gamma again is the phase angle of your current. And I am going to find the complex conjugate I star. I star will be equal to I, and you will have a negative phase minus gamma. So del is the phase of the voltage and gamma is the phase of the current. Now I am going to find the complex power. S bar is equal to V bar into I bar star. So V angle delta into I minus gamma. So this results in Vi into del minus gamma. So I am going to represent this del minus gamma as a single factor phi. So what is phi? Phi is the phase difference between voltage and current. For example, if you consider this as a voltage wave, this is voltage, and I have my current wave like this. So the current, this is 0 degree and this is 90 degree. Current lags the voltage by 90. So the phase difference between the current and voltage is 90 degree. This is called as phase difference. Okay. So which is represented as phi. So finally I write S bar as S bar is equal to Vi angle phi. Now I am going to calculate the apparent power. Apparent power is just the magnitude of S bar. What is magnitude of S bar? If I try to find the magnitude, I will have only the if I put this modulus, I will take only the magnitude alone. I will not consider the angle. So S bar is equal to V into I. Apparent power is the product of the magnitude of RMS voltage and RMS current. Now we will see in detail what is the power triangle. Now I told you the power is a complex power. Complex, you know what a complex value is. If I have a vector or a complex value A bar, it will be equal to x plus jy. So x is the real part and y is the imaginary part. Similarly, when we talk about complex power, I will have the real part and the complex and the imaginary part. So this imaginary power is called as reactive power, and this real axis power is called as an active power. So the first diagram tells you if phi is positive. If phi is positive, that is the phase angle between voltage and current is positive, I'll have a triangle as this. And if phi is equal to 0, then my complex power is equal to active power and Q is equal to 0. I tell you why. What happens. And similarly, when you see this, when you have minus phi, when your phase angle is negative, then you will have P is equal to S cos phi and Q is equal to minus S sin phi. Okay. So now coming to this, S bar is equal to VI angle phi. So the real part is the active power. You can see this VI cos phi plus JVI sin phi. Active power is measured in watts and reactive power is measured in volt ampere reactive. This is the unit for reactive power. Now P is equal to S cos phi. Q is equal to S sin phi. I told you what happens when phi is equal to 0. When phi is equal to 0, cos 0 is 1. So P is equal to S. And sin 0 is 0. So Q is equal to 0. That's why we arrive at this condition. P is equal to S and Q is equal to 0. Now, the active power P is equal to VI cos phi in watts. W tells you watts. Now, I want to measure it in higher value, kilowatt. Then I have to divide by 10 cube. 10 cube is 1000. Or if I want to multiply by megawatt or measure in megawatt, then I have to divide by 10 to the power 6. Got it? Similarly, reactive power. Reactive power is VI sin phi in volt ampere reactive. If I want to measure in kilovolt ampere reactive, divide by 10 to the power 3. If I want to measure in megavolt ampere reactive, divide by 10 to the power 6. Now, in DC circuit, V and I doesn't have any phase. That is, we are not in DC circuit, it is not a time varying quantity, it's a constant value. So it is not going to have any phase. Therefore, complex power becomes active power. Now, measuring energy. You all know about energy. Energy is the power and the time. Product of power and time. And it is measured in watts second. And the highest unit of measurement is watt and hour. Watt into hour. Now we are going to find power factor. Power factor is defined as ratio of active power divided by apparent power. Active power is P. Apparent power is S. And you very well know that P is equal to S cos phi. Active power is S cos phi. So in this equation, instead of P, I am going to substitute S cos phi. So S cos phi by S, which results in cos phi, where phi is the phase difference between voltage and current. So power factor is defined as the cosine of the phase difference between V and I.